Welcome to the last part of this journey on electricity. So far, we've looked at introduction to what electricity is. We also looked at static electricity. We looked at current electricity. And in this final video, we're going to take a look at practical electricity. So we're going to start with the concept of electrical energy utilization or consumption by electrical appliances, the concept of electrical power. So electrical power is defined as the rate of using electrical energy. So maybe some of you have seen electrical appliances such as bulbs having a power rating such as 100 watts or 50 watts. The rating is there to indicate how much electrical energy that appliance consumes, so that when you're using that appliance, you become mindful of the amount of electrical units you are using. So the unit of electrical power is watt, represented by capital W. So the formula for power is voltage times current. That is the formula for power. P is the electrical power in watts, V is the potential difference of voltage or EMF, and I is the current. Let's take a look at this example. A 12 volts battery is giving off a current of 2 amp to a resistor. Find the power dissipated in the resistor. So this is simple. The data I've been given is the voltage, which is 12 volts, and the current, which is 2 amps. Power is voltage multiplied by that current. Voltage is 12 volts and current is 2 amps. So this is just straightforward. We just plug in the value for V and I. 12 times 2 is going to give us 24 watts. Next, we look at cost of electrical energy. Power is the amount of energy that is consumed. Now the cost is another issue. So electrical energy consumed is in the units kilowatt hour. So when you talk of amount of electricity that is consumed, we talk of kilowatt hour. Kilowatt hour, we're talking about power expressed in kilos, and then we get that value multiplied by the amount of hours that power has been consumed. That's the cost of electrical energy. Of course, this is going to be proportional to a certain Quacha value. So this is what we call 1 unit of electrical energy. So when we say units are finished, my units are still, what we are referring to is the fact that the kilowatt hour has finished. 2 units is 2 kilowatt hours. So how to calculate the cost of electrical energy? The first thing you do is you calculate the energy consumed in kilowatt hour. About energy, I'm talking about the power. So calculate the power, but you express it in kilowatts. Then also you multiply it by the time that power has been consumed. That is the time the appliance was being used. So the energy, in short, is just power multiplied by time in hours. Next, you calculate the cost of electrical energy by cross multiplication. So usually they'll give you a proportional Quacha value to 1 unit of electrical energy. So you will say 1 unit of electrical energy is equal to this Quacha value about this amount of units that have been consumed. So we're going to do cross multiplying, as you are going to see in an example. Here is an example. A light bulb of 100 watts is used for 7 hours. What is the energy cost if the energy costs 50 kwacha per unit? So ZESCO charges 50 kwacha per unit. Alright, so in this case, what is the cost of using the 100 watt bulb for 7 hours? So first we collect the data. The power is 100 watts. Okay, which in kilowatts we just divide by 1000, it will be 0.1 kilowatt. Time is 7 hours. Energy we don't have, we have to calculate. Cost we don't have. and energy is equal to power times time. So we'll get the power and the 7 hours, we multiply them. So 0.1 kilowatt hour times 7 hours is going to be 0.7 kilowatts hour. I forgot to put the H. You have to put the H there. Kilowatt hour, kWh. Now, according to this statement here, energy costs 50 kwacha per unit. So it means 1 unit costs 50 kwacha. Okay, 1 unit costs 50 kwacha. Remember, 1 unit is 1 kilowatt hour. What about 0.7 kilowatt hour? So 0.7 units is going to cost X. So we're going to do an operation called cross multiplication. So in cross multiplication, we just multiply this times this, then equals this times this. For those who can understand what's going on here without the need for cross multiplication, we just multiply this times the cost, 50 kwacha. Right? So when you do cross multiplication, we're going to have 1 times x, it's x, and 0.7 times 50, we're going to get 85 kwacha. That's the cost of 0.7 kilowatt hour of electricity. Next, we just discuss some things that maybe we already know. Uses of electricity in homes. So whenever you're using an electrical appliance, there is a plug. So you put this plug, you plug it into a socket. So we're going to start what makes up a plug. So this is a plug. So this is a 3-pin plug where which is a plug with 3 pins, this and this. So it has been opened. This is the inside of a plug. So there are 4 main parts that we're going to take a look at: this, and this. All right. So we're going to start with this, which is called a fuse. So this fuse is a thin wire which melts when current goes beyond specification. So if the current goes above what this equipment is expected to use, this one melts. So when it melts, it breaks the circuit. In short, current, before it reaches the wherever it's going here, where there's an appliance, it has to pass through the fuse. So if the current is too much, it melts, and therefore there will be no path through which current is going to pass. Therefore, the appliance here is going to be protected from too much current that was coming. So that's the function of the fuse. It protects the appliance from being damaged by too much current. Next, we're going to take a look to discuss these 3 cables here. So the first one is called the live, which is usually brown. All right. So you have to know the colors of these because they are standard colors. Okay. So when you open a fuse, you're going to see these cables with these colors. So just from the color, you should be able to tell that this is the live, this is this, and this is this. So the live is the wire that carries the actual power, the actual electricity, the actual current. Okay. So this one is very dangerous. Don't touch it. Okay. So other than the live, there is the neutral. So the neutral, what it does, it completes the circuit. What that means is power from here will go wherever it's going to the appliance and will come back through the neutral. All right. So it can if these two are going to some sort of a battery, you can view it like positive comes here, then negative. The power that goes to the negative comes to the neutral. Okay. So usually this one is dangerous, but this also carries current. So when you touch it, you can end up being shocked. However, when okay, I wanted to bring up something, but it might be beyond the scope of this discussion. Let's go to the next wire, which is the earth. The purpose of the earth, by the way, the neutral is blue, always blue. Then the earth is green or yellow. Green or yellow. So this wire, which is called the earth, is connected to the metal casing of the plug. Okay, so this is always connected, so not of the plug but of the appliance. So the earth is always connected to the metal casing of the appliance. In case there is a problem, maybe there is some current that is leaking. To leak is to move away from the wires to go outside, such that when a person touches somewhere, they may end up being shocked. So whenever there is leakage current, this earth takes this leakage current and it takes it to the ground or to the earth. So that's the purpose of the earth. It makes sure that it takes away all leakage current, so that when a person touches this, then the person is not going to be shocked. Okay, so in summary, live wire is a brown wire. It supplies the electrical energy to the appliance. The line has a high voltage. Neutral wire is a blue wire. It makes the circuit complete in the electrical appliances. Earth wire is a green or yellow wire. It takes any unusual or leakage electricity from the live to the ground. The wire is connected to the metal casing of an electrical appliance. So, some dangers of using electricity in our homes. The first danger can come from damaged insulation. So, electrical wires are insulated. To be insulated is to be covered by a plastic material, so that the electricity inside the wire cannot get out, since plastics are bad conductors of electricity. But it can happen that as you keep on using the appliance, the insulation can get damaged, and when it gets damaged, it means the wire becomes exposed. And at some times, when you want to touch the wire, not knowing that where there's insulation, it is damaged, you might end up touching the wire. So damaged insulation can cause can bring hazard when it comes to using electricity. So the electric wires are insulated. If those insulators are removed, the live wire can be contacted to somewhere and it can cause electrical shock and fire. The other cause is overheating of cables. As too much current passes through the cables, it produces heat. So sometimes this heat can end up melting the insulation, and therefore this can cause damage to the appliance and the users. So if electric current flows in the wire, it can cause overheating, then it can melt the insulation and start a fire. The other one is damp conditions. So experimentations in the lab have shown that human bodies have easily get shocked when in damp conditions. Damp conditions are conditions which are watery. For example, if you're from washing your hands, the resistance of your hands become low, therefore you can easily get shocked, as current can easily pass through you instead of resisting the flow of that current. So in damp conditions such as wet bathroom, the current flows to the human body easily. So how do we protect ourselves from these hazards? Safe use of electricity in the house. First, earth wire. So always have an earth wire. Sometimes when lightning strikes a house, an earth wire can protect the house. When lightning is about to strike, actually, it attacks the tallest metallic object. So if there is earth wire nearby, then the earth will get that electricity and take it to the ground. Any kind of short circuits, which of course is where two wires which are not supposed to meet, which can be dangerous, earth wire can take that to the ground. Any kind of leakage current. So in short, grounds any contact of live to the metal casing. Next is double insulation. A good practice is to double insulate the wires. You insulate it and then you insulate it, so that when the first insulation is broken or damaged, there is a secondary insulation in place. So some electrical appliances are double insulated. It makes the leakage of current difficult. Next is a switch. When there is a problem, for example, stove that is on fire due to some electrical fault somewhere, just switch off from the socket. It can help reduce that. So the function of the switch is to turn on off the electrical appliances. In the case of leakage, the switch can be used to cut off the current. Finally, the fuse, which we discussed. So if too much current flows through an electrical component, the component can overheat or start a fire. The fuse prevents too much current from flowing through it. We end this topic with the discussion of this important component called fuse. So we're going to start fuse rating. For example, if your plug has a damaged fuse, how do you get a different fuse to replace that one? You have to know how the rating, how they do the rating. So the science of the fuse is as follows. So the fuse rating is the maximum current that the fuse can carry without melting. We should always choose a proper fuse rating based on this thinking. First, if we choose a large fuse rating, it allows too much current to flow. So a large fuse rating means a fuse can allow too much current without melting. Therefore, even in case there is abnormal current going to your appliance, that abnormal current can pass and end up destroying your appliance. Second, if we choose a small fuse rating, the electrical appliance doesn't work. So if the fuse can only allow very small current, smaller than what your appliance can handle, or the operating current of your appliance, the appliance won't be working. And if you try to pump in too much, or actually not too much, but the actual current for your appliance, the fuse can melt because it cannot handle large currents. So the fuse rating should be slightly larger, just slightly larger than the working current of an appliance under normal operations. So if your appliance, if you see that your appliance works with maybe 5 amps, then you can choose 6 amps, just a bit high, not too much, but just a bit high. Okay, but there are standard fuse rating out there. So these are available fuse ratings. So there's 3 amps, 5 amps, 13 amps, 15 amps, or 30 amps. So if your appliance works with 12 amps, you can choose the 13 amps. It's the one that is closest to 12. If your appliance works with 4 amps, you have to choose the 5 amp because 5 is a bit bigger than 4. You can't choose 3. 3 is smaller than 4. You have to choose slightly larger than the working current. Let's do an example. A refrigerator is rated at 240 volts, 48 watts. Which fuse should be used, 3 amps or 13 amps? So they have given us the voltage, the power. Now we need the current. We use the formula for power, which is voltage times current. So here we'll solve for current, or we can plug in the values and then solve for current. So power is 480, voltage is 240, current is I. We can divide both sides by 240. When we do that, we're going to get 2 amps. That's the current. So our refrigerator needs 2 amps. So which one should we choose, 13 amps or 3 amps? If we choose 13 amps, it is too large. It can allow an abnormally large current to flow and therefore destroy our refrigerator. But a 3 amp is slightly bigger than the 2 amps, so we'll choose the 3 amps. So this is how to do fuse rate. So this marks the end of electricity. Hope you have enjoyed the entire topic. Otherwise, happy solving.